Hi, in this video, we will dive into solving quadratic equation using the completing the square method. Due to some quadratic equations that are not factorizable, that is, they can't be expressed as a product of two linear factors, the method of completing the square becomes appropriate for finding the roots or solution of such quadratic equations. But before we dive into the full concept of completing the square, let's first understand the idea of perfect square, which will be very important in using the method of completing the square. Now, example 1 says, what must be added to the following expressions to make them a perfect square? So A is a squared plus 6a, and B is h squared plus 2 divided by 3 multiplied by h. Solution. Now, we have that a squared plus 6a. We are asked that what must be added to this expression to make it a perfect square. So from here, the first thing we do is to multiply the coefficient of a by half. So we have that this is 6 times 1 divided by 2, which is equal to 3. And the next thing we do is that we square the result and add it to the equation. So if we square this will be 3 squared, which will be equal to 9. So therefore, we have that a squared plus 6a plus 9. So 9 must be added to the equation to make it a perfect square. So the next question says h squared plus 2 divided by 3 or multiplied by h. Now we are asked that what must be added to this expression to make it a perfect square. The first step is that we multiply the coefficient of h by 1 over 2. 2 divided by 3 times 1 divided by 2. So 2 can cancel out 2. So we have 1 divided by 3. And then the next step is that we square the result and we add it to the expression. So we have 1 divided by 9. So our expression now becomes h squared plus 2 divided by 3h plus 1 divided by 9. So therefore, 1 divided by 9 must be added to make the expression a perfect square. Now, let's dive into the full concept of completing the square. Example 2 says, solve the following quadratic equation using the completing the square method. So our question 1 is 4s squared plus s minus 1 is equal to 0. The first thing we do here is that we move the constant term to the right hand side. So our equation becomes 4s squared plus s is equal to 1. Now note that for us to be able to use the completing the square method, the coefficient of s squared should be equal to 1. So we divide our equation by the coefficient of s squared, which is equal to 4. So we divide here by 4, divide here by 4, and divide here by 4. So 4 cancel out 4. Our equation now becomes s squared plus 1 divided by 4 multiplied by x equal to 1 divided by 4. Now the next step here is to multiply the coefficient of s by 1 divided by 2 and square the result. So we have that the coefficient of s is equal to 1 divided by 4. We multiply by 1 divided by 2, which is half. This is equal to 1 divided by 8. So we will square the result and add it to both sides. So we square the result, and our equation becomes s squared plus 1 divided by 4 multiplied by x plus 1 divided by 8 all squared equal to 1 divided by 4 plus 1 divided by 8 all squared. So factorizing the left-hand side, we have x plus 1 divided by 8, all enclosed in the bracket squared, is equal to 1 divided by 4. Simplifying 1 divided by 8 squared, we obtained 1 divided by 64, because 1 squared is equal to 1, 8 squared is equal to 64. Now, we can write that x plus 1 divided by 8 all squared equal to, since 4 is a factor of 64, so our LCM is 64. 64 divided by 4 is equal to 16. 16 times 1 is equal to 16. Plus 64 divided by 64 is 1. 1 times 1 is 1. So this can be written as 17 divided by 64. So therefore, we have that x plus 1 divided by 8 all squared is equal to 17 divided by 64. Now from here, if we take the root of both sides, we have that x plus 1 divided by 8 will be equal to root of plus or minus 17 divided by 64. This can also be expressed as x plus 1 divided by 8 equal to plus or minus root of 17 divided by root of 64. So we can obtain that x plus 1 divided by 8 is equal to plus or minus root of 17 divided by, now 64 is a perfect square, so we have that square root of 64 is equal to 8. Now from our left hand side, we move 1 divided by 8 to the right hand side. So we have that x is equal to minus 1 divided by 8 plus or minus root of 17 divided by 8. Now since we have 8 and 8 as the denominator, we take LCM. So we have that 8 divided by 8 is 1. 1 times minus 1 is minus 1. Plus or minus 8 divided by 8 is 1. 1 times root 17 is giving us root 17. So for plus, we have that s is equal to minus 1 plus root of 17 divided by 8. And for minus, we have that s is equal to minus 1 minus root of 17 is equal to 8. So therefore, s is equal to 0.39 or s is equal to 0.64. Now, if you know you have found value in the video as we proceed, please don't forget to subscribe and hit the like button. And also, if there is any step you didn't understand, please ask question and we'll reply you. Let's solve number 2 question. Number 2 says 2 plus 3 divided by y equal to 2y. So the first thing we do here is to multiply our equation by y. So we have that this becomes y multiplied by 2 plus y multiplied by 3 divided by y equal to y multiplied by 2y. So we have that 2y plus y times 3 is 3y. 3y divided by y is 3 equal to y times 2y is 2y squared. So if we rearrange our equation, we have that 2y squared minus 2y minus 3 is equal to 0. Now we can now solve using the completing the square method. So the first thing we do here is to move the constant term to the right hand side. So we have that 2y squared minus 2y is equal to 3. Now we divide through by the coefficient of y squared, which is 2. So here will be divided by 2, divided by 2, and divided by 2. So 2 can cancel out 2, we'll be left with y squared. 2 also can cancel out 2, so we'll be left with negative y equal to 3 divided by 2. So the next step is to multiply the coefficient of y by half, square the result, and add it to both sides of the equation. The coefficient of y squared is negative 1, so multiply it by 1 divided by 2, which is equal to minus 1 divided by 2, and then we square the result and add it to both sides. So our equation becomes y squared minus y plus negative 1 divided by 2 all squared equal to 3 divided by 2 plus negative 1 divided by 2 all squared. We can factorize our left hand side. Our equation becomes y minus 1 divided by 2 all squared equal to 3 divided by 2. Minus 1 squared is 1, and minus 2 squared is 4. So we have that plus 1 divided by 4. In our right hand side, we can take LCM, which is 4, since 2 is a factor of 4. So 4 divided by 2 is 2. 2 times 3 is 6, plus 4 divided by 4 is 1. 1 times 1 is 1. This is equal to 7 divided by 4. So we have y minus 1 divided by 2 all squared on our left hand side. So our equation is now simplified to be y minus 1 divided by 2 all squared equal to 7 divided by 4. Now if we take the root of both sides, we have y minus 1 divided by 2 equal to plus or minus root of 7 divided by 4. So we have that our equation becomes y minus 1 divided by 2 equal to plus or minus root of 7 divided by root of 4. This can be expressed as root of 7 divided by 2. Thus, we have that y minus 1 divided by 2 is equal to plus or minus root of 7 divided by 2. Now to make y our subject, we have to move minus 1 divided by 2 to the right hand side. So we have that y is equal to 1 divided by 2 plus or minus root of 7 divided by 2. So since 2 is common in our denominators, so we have that y is equal to, taking LCM to be 2. 2 divided by 2 is 1. 1 times 1 is 1. Plus or minus 2 divided by 2 is 1. 1 times root 7 is root 7. So for positive, we have that y is equal to 1 plus root 7 divided by 2. Also, for negative, we have that y is equal to 1 minus root 7 divided by 2. With the knowledge of completing the square, we can now be able to derive the quadratic formula. Using the completing the square method, derive the quadratic formula. Solution. Our general equation is given as as squared plus bs plus c is equal to 0. From our knowledge of completing the square, we can be able to derive the quadratic formula. So the first thing we do here is to move the constant term to the left-hand side. So we have that as squared plus bs is equal to minus c. And recall that for us to use the completing the square method, the coefficient of x squared will be equal to 1. So we divide through by the coefficient of x squared, which is equal to a. So a here can cancel out a. We obtain that s squared plus b divided by a multiplied by s is equal to minus c divided by a. Now, the next step is that we multiply the coefficient of s, which is b divided by a, by half and square it. So we have that b divided by a multiplied by 1 divided by 2 is equal to b divided by 2a. Now, we are going to square it and add it to both sides. So we square it and add to both sides. Our equation becomes s squared plus b divided by a x plus b divided by 2a all squared equal to minus c divided by a plus b divided by 2a all squared. From our left-hand side, we can factorize. We have that x plus b divided by 2a all squared is equal to minus c divided by a plus b squared divided by 4a squared, because 2a squared is equal to 4a squared. From our left-hand side, we have that x plus b divided by 2a all squared. So from our right-hand side, we have denominator a and 4a squared. So therefore, our LCM is 4a squared. So 4a squared divided by a is 4a. 4a times minus c is minus 4ac plus 4a squared divided by 4a squared is 1. 1 times b squared is equal to b squared. So therefore, we can have that x plus b divided by 2a all squared is equal to, we can rearrange our numerator. Our expression becomes b squared minus 4ac divided by 4a squared. Now, if we take the root of both sides, we have that x plus b divided by 2a is equal to plus or minus the root of b squared minus 4ac divided by 4a squared. First, our right hand side becomes plus or minus root of b squared minus 4ac divided by root of 4a squared. So our equation becomes plus or minus root of b squared minus 4ac divided by 2a. And we bring down the expression in our left hand side. So we have x plus b divided by 2a. Now to make s our subject, we move b divided by 2a to the right hand side. We have that x is equal to minus b divided by 2a plus or minus root of b squared minus 4ac divided by 2a. Now, since we have the same denominator, we can arrive at x is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. We have been able to derive the quadratic formula from the general equation using the completing the square method. Please, if you know you find value in this video, don't forget to subscribe or like the video. It encourages us to make more videos. And please comment and share the video. Thank you, and I will see you in the next one.